So most people are in the webinar right now. So we can start now. Good day, everybody. Thank you all very much for joining today, and welcome to this technical webinar in which we will explain how the hybrid PLC&RF solution works. In 2020, the G3 PLC Alliance decided to develop the first open standard for hybrid PLC&RF communication, and now, 1 year later, we have published the hybrid specification, and we launched the certification program just earlier this month. And we will have the first certified hybrid devices very, very soon. So we are very pleased that we can now welcome you to this session explaining how the hybrid technology actually works. My name is Leon Vergeer, and I'm the General Secretary for the G3 PLC Alliance. And in the webinar today, we have real experts available for you to explain how the technology works and to answer all the questions you may have. I will briefly introduce the people, and then we'll go to the actual presentations. Cédric Lavenue, he is from EDF R&D and is heading the technical working group in the G3 PLC Alliance. Matteo Faresio from ST Microelectronics in Italy will make a presentation. David Sancho from Microchip is joining us today, as well as Kevin Jones from Renaissance and Vincent Marie from Trialog in Paris will be in the presentations today. And all these people actually actively participated in developing the specification, so they really should be able to answer any of your questions in this session today. So what agenda did we prepare? Cédric Lavenue will start by introducing the hybrid solution and explaining a little bit about the next steps in the development. Then Matteo will explain about network discovery and Bootstrap. David and Vincent will tell you all about building routes over the hybrid profile. And then Kevin will talk about introducing hybrid nodes into existing PLC networks. Then after that, we should have time to answer any questions, to make any further discussion. So if you have any questions during the webinar, please post them in the questions box in the control panel, and then we can either address them right after the presentation or at the end of the webinar in the discussion. After the webinar, we will share the presentation with all of you, as well as the recording of the session. So I think that's it for the introduction, and not to lose any further time. Cédric, I hand over to you for the first topic, if it's okay with you.
Yep, thank you. Hello, everyone. Welcome also to this webinar on my behalf. So thanks for joining. I'll try to introduce the hybrid PLC&RF solution, trying to understand why we made this development, and progressively we will go to the details of the solution, so what it consists of. So next slide, Leon, please. So basically, on the right side, you see a typical hybrid network where you have one PAN coordinator, so PAN-C, the ping device, which is managing a hybrid network consisting of the black nodes, the black hybrid devices. And you can see either communication is done using power line communication, so G3 PLC, so the green links, or you may use radio frequency media between each of these nodes. Of course, these media can change over time, and node nodes can of course dynamically adjust the media they use to reach the destination. So basically, when we use both G3 PLC and RF media, we really manage to maximize coverage and resilience of the resulting, thanks to the resulting mesh topology. Right. Next slide, please, Leon. You will also, because of that, provide a really efficient solution for many use cases such as smart grid, smart city, and it really enhances the relevance of the G3 PLC technology. Next slide. And the goal also of doing this is because while enhancing the actual use cases where G3 PLC is already used for, we really think that the hybrid will extend G3 PLC capabilities much beyond smart metering. So I already pointed to smart grid and smart city, but you can also imagine lighting control, building automation, demand response, and already existing railway application also having G3 PLC. So here the hybrid really helps to do that. And in the next slide, we show that this is not different from what is already what G3 PLC already aims at, as it's a multi-purpose technology. And with a hybrid profile, we can even further leverage its capacity to address multiple and many application use cases. On the next slide, please, Leon. So here, the first question that we ask ourselves when we started development is which radio frequency technology to choose. You probably know the picture on this slide here, where each RF, or it's not exhaustive, of course, but you have a lot of different well-known RF technologies that are classified, taking into account the range and data rates that is obtained, and the criteria to choose which standards to implement. It's basically about having an open standard. We would like to avoid vendor lock-in, and we want to reach interoperability. So that's first very important criteria, also echoing the spirit of the G3 PLC Alliance. We need, of course, a compatible data rates. You would have some technologies that would be too low with respect to G3 PLC, others that would be much too high data rates. So that's also one important thing to take into account. We need a technology that could be deployed in a private owned network. We cannot rely on cellular technologies, for example, that rely on the telecommunication operator infrastructure, at least as the way they're deployed mainly. In terms of range, kilometer range would be the preferred option as well. We will have star and mesh topologies up to a few kilometers probably. And then we had to choose between lower layers and communication profiles. And as we will show in the next slides, of course, it's important that you get this connection to maybe just a phi and meg of the technology. And that's why we made the choice of IEEE 802.15.4, which, by the way, is already the baseline for G3 PLC. So it's an easy choice, an easy match to the actual protocol stack. And we decided to use the FSK phi, the Smart Utility Network FSK phi that is defined since IEEE 802.15.4G amendment, also used by some alliances for some specific technologies. But here we make use of the IEEE standard and we adapt it to our hybrid profile. Next slide, please, Leon. So the result is this protocol stack you can see on screen. As a reminder, G3 PLC really defines everything between phi and above, just above 6LoWPAN. IPv6 is out of scope of the G3 PLC Alliance definition. So here we basically add parallel phi, so the Sun FSK phi, a parallel RF MAC, and we have a hybrid abstraction layer. You can see in blue here. which basically allows to switch between the two lower layers for PLC and for RF, and you make these choices as we will also present it afterwards. But everything is done to make this as transparent as possible to the 6LoWPAN, in which we keep the existing LOADng routing protocol, we keep the low-band Bootstrap protocol that is responsible for managing the devices, making them join the network and maintaining it over time. So that's really done in a very, very transparent way from a G3-PLC stack point of view. It's even very transparent to the application layer, because all of this is totally the application layer is totally agnostic about which media is used. So it's very easy. It's very easy to use this hybrid G3-PLC profile the same way you would use a G3-PLC only, for example. And what is nice with that is you get full backwards compatibility with any G3-PLC network. So you may put one or several nodes in an existing G3-PLC network to do some extensions with RF, whatever use case could be, and this we will address it also later today. And you could, of course, have your 100% hybrid network also with that. So we consider that here PLC is still the primary medium and RF is considered the secondary medium. So on the next slide, I will try to enter a little bit more the different layers of the protocol stack, starting with PHY and MAC. For the RF part, for G3-PLC, it's already quite well known. So as I said, the SEM-FSK PHY is defined according to 2015 and 2017 Amendment V specification of IEEE 15.4. So this is just for the normative references. We, in the first step, we support the 863, 870 megahertz band. That's what it is about when we certify devices in the program that has been launched recently. We use unslotted CSMA-CA for non-beacon enabled networks, so something very similar to what we use for the PLC part already. Radio frequency information is also shared between neighbors using information elements. So that's one of the reasons we chose to keep 802.15.4 2015 MAC to use this information element feature to share information between neighbors, same way as G3-PLC uses, for example, TOMAP response, and negotiate the modulation and the channel used for communication. We do something similar with the information elements, where we can exchange duty cycle information, link quality information, so that all devices maintain this RF information in dedicated date table, which we call an RF post table. According to IEEE terminology. So when we go to the upper layer, so in the next slide, so we'll talk about this hybrid abstraction layer, and actually this abstraction layer doesn't do much. Basically, it basically defines the media types. So as you can see on the table on the right side, you either choose to use PLC with RF as a backup. You can choose RF with PLC as a backup. You could use both PLC and RF interfaces. This is quite useful when you're having broadcast traffic, or for beacons. You don't know beacon requests. You don't know over which medium you may receive a response. So that's what you would use. But you could also use PLC or RF, so media types 3 and 4, without any backup interface. So that's what the hybrid abstraction layer defines. And then it's defines a set of primitives that just makes the link between the MAC service primitives and the 6LoWPAN layer. So we have YAL, that's the way we call them, hybrid abstraction layer. Data, request confirm indication for data traffic, and we have also a set of primitives to ensure more specific PAN information to be propagated to the high layers, such as typically the scan, the YAL scan primitives, which allows to discover the environment and to join the network. As I said, it ensures it's and deals with the second transmission attempt using a backup media if this is actually selected in the media types. So for media type 0 and 1, where RF or PLC could be used as a backup if the primary interface, the PLC or RF, does not work for the appropriate transmission. On the next slide, that's almost the end of the presentation for my part. I just wanted to shed some light on the way the adaptation layer is shared between the two media. As I said, there's almost no change. The only thing that changes is to add a media type field in both routing table and blacklist table entries, where we can specify. So for the route table, that's quite straightforward. We specify explicitly over which media we should forward a packet when trying to reach a destination. So which is the media to the next hop to the destination, PLC or RF, and you would use the media types defined in the slide before. And in the blacklist neighbor table, you could eventually blacklist RF or PLC interface for a specific neighbor in case of delivery failure. And if you have that, you would typically force forwarding of the backup medium for the next transmission attempt, so you avoid losing time in retries. And finally, the last slide as far as I'm concerned. So next slide, Leon, please. Yeah, so what I want to finish with is to say that basically RF and PLC link selection is done during the LOADng route construction process. LOADng is actually making the choice and routes are constructed exactly the same way they are in G3 PLC only. You would just update the metric with 2 more weighing factors, which are duty cycle consumption and of course the RF link quality. So you would adapt this link metric for an RF link, and this would be considered for RF link. For PLC links, you would mix the different metrics, and you would still choose the best route according to the final route cost you have towards the destination, as we already do with LOADng in G3 PLC only. So to really, you have the route table penalty to avoid fitting too much to your routing tables. You have the hop count penalty to avoid having too many hops to the destination. So that's already existing also in PLC. And then we have the link cost penalty. So we also have link cost penalty in G3 PLC. Here we just use link cost derived from the RF, SNR, and LQI. And finally, we have a duty cycle penalty because there's a lot of regulation where you cannot transmit continuously. So you make sure that you avoid using too much the same neighbor when forwarding messages. So that's basically the update you make to the link cost. Thanks for listening. I will then hand over just maybe to Leon and then to my colleagues.
Yeah. Before Matteo takes over, one short question we received, Cedric, is can you briefly tell a little bit about the standardization of the hybrid solution and the DLMS COSM profile?
Yeah. Oh, okay. So two things to be aware of. So G3 PLC now teams with ITU since a few years and updates ITU TG9903, which is the reference ITU standard for G3 PLC. So right now we are actually we started a revision cycle, so an amendment embedding the hybrid profile as an annex is on the way. So we hope that the ITU process will be completed soon. I would say that we expect this by end of Q2, but you never know. In standardization processes, things can take longer. So but that's the goal. As far as DLMS COSM is concerned, there's also something we have clearly tagged as an important thing to do this year, is to actually put all the RF specific attributes, let's say, to configure the stack, to put them into GLMS COSM interface classes, in addition to the existing G3 PLC ones. So this is also something we expect to do this year. Right.
Yeah. All right. Thank you, Cedric. Then.
Thanks to all.
Matteo, we'd like to hand to you.
Oh yeah, I forgot just one thing about the.
Sorry. Yeah.
Yeah, indeed, there was the slide about the next step. Just to say that before I hand over to Matteo, that we're working on the introduction of new operating frequencies and of frequency hopping to tackle a lot of different regulations and regions worldwide. And we, of course, consider the support of battery-powered device in the future. So sorry for this, but this is an important addition you need to consider. Thanks.
Yep. Thank you. Then, Matteo, now we're really over to you.
Okay, thank you, Leon. Thank you, Cedric. I'm going to talk a little bit about the network discovery and Bootstrap. So let's start with the network discovery. That means when the G3 devices are powered on, so the first thing they have to do is indeed to search for other networks and for other devices to join the network. So there are two steps. First, the network discovery, and then the Bootstrap. The Bootstrap is it happens in a second step, and it is the process to get the addresses and the keys used for encryption to really join a network. So regarding the discovery, it is handled by exchanging beacon requests and beacon messages. In the example we are showing in this slide, there is device X that is discovering, that is trying to discover the devices that are already in the network, and we can see that is transmitting the beacon request message on both interfaces. So it will send device X will send beacon request over PLC and over RF medium. So there are some in this network. In this example, we have some G3 PLC only devices as A and C. Indeed, as Cedric said before, the hybrid G3 hybrid specification is compatible with G3 PLC only devices. So those devices A and C receive the beacon request messages on PLC only, obviously. In this example, we have a device that is device D on the bottom that is connected only through RF. We can suppose that the PLC link is really weak. So device D receives the beacon request only on the RF medium. And we have device B that is receiving the beacon request coming from X on the two interfaces. Okay, what's next? The devices, you can switch to the next slide, John, please. Okay, great. So the devices receiving the beacon request will reply to that with the beacon message. So the idea in the hybrid specification is that the beacon is sent on the media on which the beacon request is received. So A and C will reply sending the beacon on PLC only. Device D, which did not receive the beacon request from X on the PLC, will reply only in RF, and the device B will reply with the beacon using both media. So now X, to complete the discovery process, will collect all the information. We can jump to the next slide, John. Okay, so at the end of the discovery process, the hybrid abstraction layer scan confirm will send to the higher layers all the pan descriptors collected both from MAC, from PLC MAC and RF MAC. Pan descriptor is the information gathered from each beacon message received from X. The important thing to underline here is that okay, so some of them are obvious. So the beacon received from PLC, so A and C. In this case, only one beacon is received, so it will generate only one pan descriptor. So we will have X. We will have the information received from A and from C about the link quality to A and C measured on PLC, and also the information contained and carried by the beacon, so the root cost from A and C to the pan coordinator. But in case the beacon is received twice, one from the PLC medium and one from RF medium, the hybrid abstraction layer generates two different pan descriptors. One, of course, some information is shared. For example, the root cost from B to the coordinator will be the same for both pan descriptors, but LQI will be different. There will be, in one case, it is computed over the PLC link, and in the other case, it is computed on the RF link. So now the device X will have to choose the agent to start the Bootstrap with. And it will do that based on the information that you get from the pan descriptors, that is the link quality of the various beacons and the root cost to the coordinator. In this example, for example, we see, you can go to the next slide, please, Leon, that device X is choosing as an agent the device B. And it chooses to start the Bootstrap with the RF medium. So we can suppose that in this case, the device B has a lower root cost coordinator compared to the other devices, and that the link quality measured on the RF medium, it was higher compared to the PLC link. Now the Bootstrap phase is starting, so X will send joining messages to the pan coordinator relayed by B. On the other side, the pan coordinator is replying with Bootstrap messages, the challenge messages in this case, to device X relayed by B. Now we are encountering an issue that was not present in the PLC. Indeed, the device X at this point in time does not own a 16-bit address. It is using a 64-bit address to transmit to device B. So it cannot be put inside B's routing table. And when device B has to relay to device X the Bootstrap messages, it does not know, is not aware of which media type has to use to transmit to X. So B gets a message from the pan coordinator and says, okay, now on which medium do I have to transmit, PLC or RF? You can go to the next slide, Leon, please. And okay, indeed, when we developed the hybrid specification, we modified the Bootstrap protocol, adding a bit, so a new bit, exploiting some reserved fields, just to say which kind of medium the LBA, so the agent, has to use to transmit to X in this case. So when X is sending the Bootstrap messages, it will set this bit accordingly to the media used. The pan coordinator receives the Bootstrap message from the agent, and when it builds the response, it will copy this bit. It will use the same values. In this way, the agent it gets the message from the pan coordinator. It looks to this bit and is aware of the media type to be used transmitting to X. So if X transmitted using RF, the agent getting the message back from the pan coordinator knows that it has to transmit to X using the RF medium. Otherwise, it knows that it has to transmit to the PLC. Anyway, another important thing to say about that is that this is an optimization we added in the hybrid specification, but as Cedric said before, everything is compatible with G3 PLC only devices. So if we attach a hybrid device to the network, it will join anyway to the pan coordinator, to the existing network. If this feature, if this bit is not employed, the agent will detect it because the field will be not used, and so it will try to reach the bootstrapping devices using PLC first, and then if the transmission fails, it will use the RF as a second attempt. Okay, go ahead, please. Yeah. Okay, last slide from my side. This is to highlight the modification on the Bootstrap commands on the ADP layer. Indeed, Cedric before said that the hybrid, adding the hybrid abstraction layer is really transparent to the user. This is 100% true for the data transmission and receiving primitives. To handle the Bootstrap, the parameter media type, so the media type parameter has to be added, for example, in network join and in the network join primitive when the application call this primitive to join the network. The media type is also added in the pan descriptor that is collected during the DPM discovery confirm. And also on pan coordinator side, when dealing with Bootstrap messages, the media type parameter has to be added. So it is quite straightforward. Okay, thank you, Leon. It's done.
Yeah, thank you, Matteo. Well, you're not done yet. There was one question I hope you can answer.
Yeah.
What is the limit of number of discovering nodes for a bootstrapping device?
I think the question is how many devices can get inside a discovery. So how many pan descriptor a device can receive during the discovery phase? Well, there is no limit inside the G3 PLC and also hybrid specification. There is no limit. It is more a limit got from the implementation. So it is an implementation choice, probably limited by the memory consumption. But theoretically, there is no limit about the pan descriptor, so the devices that a node can hear when discovering a network.
Okay, I hope that answers. Otherwise, we can discuss at the end, maybe.
Yeah, sure.
Okay, then I'd like to move to the Vincent. I think that's you to move to the route building in the hybrid technology. Yes. We have to look a little bit at the time. So please start.
Okay, let's start. So next slide, please. So first I will go very rapidly on how routes are built on PLC profile. So what is done, for example, in this case was the sender A that tried to find the route to Z. And so what he's doing is sending a broadcast route request messages on the network with the destination to Z. And as you can see, the message propagates on the network with a quality depending on the distance. And each node that receives the route request will compute the route cost based on the formula and populate its routing set with the route back to A with the cost computed. So you can see that the cost augment with the distance. So higher route cost is worse. Next slide, please. Next, yeah, okay. And then each node will repropagate the route request, adding that route cost to the messages, so it's cumulative route cost. And if a node receives several route requests, which will be the case in practice, it will only propagate again if it receives a better route cost value. If not, it will discard the message. So here you can see some of the row propagation. And for example, you have the node K that received from F that will create entries in the table saying, okay, to go back to F, it costs that much. To go back to A, it costs the cumulative amount, and so on. And this will propagate on the whole network. Next slide, please. And at the end, when Z will receive route request, it will receive a lot of route requests from various paths, and we choose the best one toward A, and send a route reply in unicast towards the route is choose as the best one, and this will propagate the routing tables with the forward path. And so at the end, you have complete routing tables allowing to go in both directions. Next slide, please. So what changed in the hybrid profile? Not much. The same principle apply. The routing set, the routing table has now a medium information saying which medium is to be used for a given hop in the route. And the broadcast route requests are sent on both PLC and RF, meaning that hybrid device will receive potentially route requests from PLC and from RF, and so evaluate them as two separate route requests, compute the route cost depending on the PLC or RF formula, and choose the best one. So it's the exact same principle. The only thing is you can have route requests coming from PLC or from RF. And this information you put on the routing table. For example, here, F will prefer RF from A because the route cost is lower. And we have separate route cost formula because we need to take into account specifics for RF or PLC. So what is specific to the quality evaluation of a link, and also you control the parameters, meaning that you can choose what you prioritize between RF and PLC. Basically, if you want to prefer PLC, you can just augment how much RF link will cost, and it will not be used if there is a PLC alternative. Next slide. The result route that can be established here can use PLC or RF for any hop in the route. So this lets you use the optimal medium for each part of the path in the network, and the result is you can mix PLC only and hybrid nodes because the behavior is basically the same, and if you have PLC only nodes, the only difference is that it will propagate on PLC, and that's the only difference. From the hybrid point of view, it just receives less route requests. So for route establishment, that's all the difference with hybrid. Next slide, I think it's for David. Yeah. So that's the end of my intervention.
Before we go to David, one question maybe, Vincent, you can answer. It's about the additional route establishment traffic. Can that cause issues in the communication in the hybrid solution?
Normally no, because the PLC and RF the bandwidths are not shared. So the fact that you have twice as much message doesn't consume more bandwidth because it uses the two medium at the same time. And in terms of treatment on the receiver, you only consider the one route request at a time, so there is no more memory consumption. So hybrid won't change on the spot.
Okay. And is there any preference for RF or for PLC routes?
So as I said before, you can configure the routing cost to express a preference for RF or PLC, and the default in the hybrid solution will prefer PLC because we know that better. But you can change the configuration if you need to.
Okay, thank you. The other questions I think we can answer later in the discussion.
Okay.
Then David, can I ask you to continue, please?
Yeah, sure. Good morning, everyone. I will talk about the route maintenance on the hybrid profile. This route maintenance is slightly different than from the previous PLC-only implementation to take advantage of having two different media to choose, okay? So it exploits the possibility of using the other medium in case data delivery fails. In case of this other medium is available and delivery succeeds, what will happen is that instead of breaking the route on the medium that failed, we will keep using this backup medium temporarily. To achieve this, a blacklist table will be used along with the routing table. This was briefly introduced by Cedric before. And before trying to use the backup medium, we will rely on the post table information. We will see these in the following examples to be more clearly. Just to say that this temporary invalidation of route its main advantage is to avoid a route repair mechanism flooding, and given that the backup medium is available, we will avoid this flooding and we will let the channel clear for successive data traffic. So let's move to the next slide to see the examples. Okay, let's see the case that we have two nodes that are capable to communicate in PLC and also RF. Let's suppose that node A has to send data to node B, and the routing table states that the data will be delivered through PLC. The data request will be done through PLC, but it will be allowed the backup medium usage. Okay, so in the positive case, if delivery through PLC succeeds, the route will be refreshed, meaning that its valid time will be reset to the maximum value. Okay, no difference here in the positive case. But moving to next slide, we will see what happens if the PLC fails in data delivery. As the backup medium can be used, we will first take a look at the post table in node A, okay? And as the figure shows that RF is in range for node B, let's suppose that we have seen some RF message previously from B. Okay, so we will find an entry in the post table. Then we will try to use this backup medium, which will be RF in this example. And assuming this backup medium succeeds, this is indicated by the hybrid abstraction layer. So what happens in the LOADng is that PLC is blacklisted, but the root is not broken. Okay, so as long as the blacklist entry is present, in case we have to send another data packet from A to B, instead of using PLC as stated by the routing table, as it is blacklisted, we will use directly the backup medium, okay, until the blacklist entry expires. So this is the way that this temporarily invalidation of the roots is managed using the blacklist table. Next slide, please. And in case that the data delivery also fails in the backup medium, what happens is that both media are blacklisted, as seen in the figure, PLC and RF, and here the root is broken, and a new root repair process will be triggered following the process that Vincent explained earlier. Okay, let's move to the next slide to see what happens in case, for example, RF is not in range, or we are talking against a PLC only node, which for this case is the same behavior. Okay, as in case one, data will be sent through PLC, indicating that the backup medium is allowed. And the positive case is just the same. PLC works, and then the root is refreshed. Okay, next slide, please. We will see what happens if PLC fails here. Then, in both cases, either because RF is not in range, or either because B is a PLC only node, we will not find any entry in our post table for node B in RF. Okay, so in this case, the backup medium is not even tried, and it is indicated to LOADng by the hybrid abstraction layer. So the root is immediately broken, the PLC medium is blacklisted, and the root repair process will be triggered, as in the previous example. Okay, so this is how the roots are maintained, invalidated, or broken in the hybrid profile. That's all from my side.
Okay, thank you very much, David. If anybody has a question, please post them in the control panel, and then we will answer it online or in the discussion in a few minutes. But before we go to the questions, we have one topic to cover. Kevin, can I ask you to
Perfect. Thank
explain
you.
about
Thank
the
you,
next slide? All right.
So next slide then, please, Leon.
There it is.
Okay, so yeah, good morning, good afternoon, guys, or everybody. Yeah, so thanks very much for the presentations earlier. What we've seen then is actually how devices can scan on the network in both mediums, on RF and PLC. We've seen how they then bootstrap to the network, how they join, and how they form routes. And basically, we've seen that that's quite a simple mechanism by just extending, in most cases, a media type field in some of the frame propagations and things like the pan descriptor lists. So actually, this means we can combine the benefits basically of the existing G3 PLC. So just to touch on those slightly, we still use the latest cryptography with the AES 128 for securing data. both channels, as Cedric mentioned, the RF mechanism, the 802.15.4 RF layer, the SunFSK, was chosen basically for its similarities to PLC. So by that we mean it's a very robust RF mechanism and offers a similar data rate on the PHY layer, and also a good range and a good robustness in terms of performance. And that also means we can still use the IPv6 datagram. So we'll talk here a little bit about the introduction of hybrid and use cases, but that means with IPv6 there's billions of addressable spaces, so that opens up the market for Internet of Things. And one other part actually from the G3 PLC Alliance is the certification platform. So all products and platforms undergo very robust certifications. So generally there's an interoperability testing, which is about testing the PHY, the MAC, and some other test cases, and there's about 40 of those. With the G3 conformance test, then there's approximately over 130 conformance tests that each product and platform has to go through. Not to mention then for products, the performance certifications. So we've seen the backward compatibility, we've seen how the interoperability works. Just quickly from the Alliance side as well, we've been working over the last 6 months on the hybrid conformance tests. So actually we're building on the existing PLC certifications, and that means for the RF devices we will have approximately an additional 80 tests for the RF conformance part. So they will need to be done by products and platforms. So that builds basically on top of the PLC. So a hybrid device will have to undergo around 200 plus conformance tests. So as you can see, the network operators themselves or utility companies can be assured that actually we're building on a very interoperable, a very compatible, and a very well tested specification. So basically, depending on the field conditions, we've seen that 2 devices can send information over the best available channel, and we maximize the coverage and resilience, as Cedric mentioned earlier. So what does this mean for a hybrid? Well, hybrid devices can be seamlessly introduced into existing networks. So we will see the next use case, maybe there's intermittent communications or not so reliable communication from a PLC side, then it's possible to just insert and upgrade a couple of meters to hybrid devices. And this allows utilities as well to upgrade the infrastructure over time. We've seen that PLC-only devices will continue to operate even with hybrid devices in the network, and that means the complete network can be upgraded piece by piece over a long period if wanted to. And obviously the hybrid nodes can be introduced from scratch also. Next slide then please, Leon. So we tried to look at a couple of the use cases, certainly from the PLC part. So no AMI and AMM technology currently offers 100% success in reading. So if we look at the G3 PLC side, then we'll advertise around over 98% success rate in reading the datas. But if we look at the map on the right-hand side, so what we can see in the green circle is a PLC-only network, and you can see there's a high concentration of PLC-only devices, and the blue pin indicates the PAN coordinator located at the medium voltage substation, medium voltage, low voltage. And what we can see actually is in rural locations, there are a few meter points where maybe connectivity isn't as reliable as in the concentration area. And this means with the introduction of the hybrid network, actually we can introduce an RF or possible backup RF medium in these locations. So as I've mentioned, and as Cedric mentioned, the RF technology being based on SunFSK, well, in the 868 megahertz band range, so that's a European band range, then the range is over 2 kilometers. It can be up to tens of kilometers, certainly in outdoor suburban areas with clear line of sights. So hopefully that can then improve the limited connectivity in certain areas. And the initial trials so far of the G3 hybrid are showing reading rates of 98 to 99.7. So really just pushing that extra 2%. So we can see it already offers a high reliability. From a network operator side of things, those last 5% of devices, or last 2%, if you like, of the meter points become very expensive to read. So, you know, if you have to send a person physically to those locations, then they're generally more isolated, and they're not as simple or quick to read as a street in a city would be. So actually, the cost of doing that is a way out. Is benefiting basically the utility to pay for the infrastructure of a hybrid network rather than have the cost of reading those extra percent. So it also means that it could be some considerations when you install a hybrid network from scratch. You might want to concentrate on PLC only in a dense area, with maybe a rule that if the distance of the meter is a set X, so let's say 1 kilometer, 2 kilometers away from the PAN coordinator, then it becomes a hybrid node by default. So the flexibility, it's very, very powerful. And one other point maybe to mention there is actually with the introduction of hybrid networks, then we can maybe remove these less reliable links, or remove links where the modulation is generally robo mode. So robo mode is a lesser performance modulation from the PLC side. So if we can remove as many robo links as possible, then we can improve the performance of the existing networks. So next slide then, please. So this is just another use case where actually, again, in rural areas, you may well have two remote villages which are located relatively close together. So using the same format, the green circles indicate some PLC nodes and the blue pins indicate the PAN coordinator devices. You can't quite make out the distance here, but this distance is 200 meters. So you can see these two PAN coordinators are approximately 600 meters in physical distance. So what will that'll allow us to do is actually combine the two PLC networks by just bridging a single RF link. So the PAN coordinators are generally much more expensive than meters. They're typically a factor of 10 or 100 times the cost. So that means we can bring down the overall cost of a G3 PLC network in more rural or less densely populated areas. And not to mention, again, here we can see there's meters connected with maybe limited or less performing PLC links as isolated properties. So next slide then, please. Yep, perfect. So this is the last slide from me. Basically, what we can see is that by combining the best of the sub-gigahertz RF and the existing narrowband PLC, we can introduce the G3 technology to many other application areas as well. It provides a much more efficient solution for the smart grid and smart city use cases, having obviously the benefit of a dual band. So if we talk about the smart home, then this introduces devices such as in-home devices, which are predominantly RF, heating control systems within the home, which are generally based on RF as well, and also opens up the markets for keypads for prepayment meters and smart appliances, so white goods, which are predominantly connected over the mains network. So as you can see, it's very flexible and should open up a lot of other use cases. If we talk about smart grids and smart cities, so a smart grid is seen as the digitalization, if you like, or the autonomous control of the grid with the introduction of more smaller energy generatings like photovoltaic cells. And with the PLC then, or with the G3 network, we can actually do fault detection, and hopefully with the autonomous side of things, we can control switches to actually minimize outages and reroute electrical supply. For smart cities as well, this means environmental monitors, so pollution control, light monitoring, waste management within cities, and lots of other application areas which would benefit from a dual RF plus PLC technique, such as EV charging, street lighting, etc. And where regulation allows, actually then an extension to water and gas meter reading for RF only devices. So as we can see, then the hybrid solution maximizes the connectivity coverage and provides a much more efficient and cost-effective solution for smart grids, cities, and in the industrial applications. So that's it from me. Thank you, Leon.
Well, thank you. Thank you very much, Kevin, for this interesting presentation and use cases. As is always the risk with technical presentations, especially that it takes a little bit more time than we planned. So we are at the end of the webinar, but I would like to take a little bit more time to answer a few of the questions we still have open. But of course, if people have to leave, we understand, and you can read the answers in the. I will include the answers when I send the presentation to all the participants. So one of the questions I still would like to address. Maybe Cedric, you can answer this one. It's about security. Is the RF communication secured as well as in the PLC communication?
Yeah, thank you, Leon. So yes, it is. We basically rely on the same authentication procedure as for G3 PLC using the Bootstrap protocol, and then of course we have also ciphering at MAC layer, so it's really comparable.
Okay, thank you. Another question, Kevin, maybe you can answer that. It's about standardization regulation. What is the standard used for RF and max power transmitter, and is it RF mesh? I think it's quite a specific question, Kevin.
Okay, so the RF mesh is probably the easy side of things. So as we've seen in the LOADng, then the LOADng establishes the mesh routing, which in the hybrid can either be a PLC or an RF link. Regarding the standardization, I mean, that's a very good question. I think it's quite a difficult one. So if any of the other guys want to jump in at the end, then that's appreciated. But yes, I mean, currently the hybrid is focused on the 8 megahertz band range. That doesn't mean that we can't open it up to other frequencies. So all the other frequencies, certainly the 800 megahertz, which is used in the US and other regions, is allowed. But yes, in terms of then, if we look at the European regulation, then I think around 863 to 870 has limitations or set requirements on power levels and duty cycles, and also in the 870 to 874 megahertz bandwidth, and there's different set of requirements for power levels and duty cycles. Slightly gets more complicated as well if you delve down into the layers as well, because then different countries may well have specific different regulations for each of those bands. From a specification point of view, we can actually cover all of them, which is very, very nice. But to answer the question specifically, we would also need to know, what the application area is, because the requirements in Europe are dependent on the application, but also then the country that's of interest as well. If it's in Europe, it's relatively easy. If it's outside Europe, then obviously we'd need to delve into the regulations for that country. So maybe Leon, if whoever's asked the question wants to target exactly which country they're coming from and which use case, whether it's metering or other, then maybe we can take it offline and answer in more detail afterwards.
Yeah, sure. If you have any specific further questions or related to this question, please, we will show all the email addresses again later. So please let us know, and we will come back to it afterwards. We're also answering a couple of questions on the webinar system, as you can see. But another interesting question, I think, Vincent, maybe you can help me with that one, is in case of dense urban areas, with hybrid communication, coordinators may receive a lot, thousands maybe of nodes over RF. Could that cause any problems, is the question.
Okay, so as we saw before, the Bootstrap phase is first discovery, then Bootstrap itself. So on the discovery phase, the beacon request and beacon are very small message, and there's a random delay mechanisms that avoid the pan coordinator needing to reply to every beacon request. So that won't create more work on the pan coordinator side. And then how much device a pan coordinator is going to see will depend on how many pan coordinator you have deployed. Because basically each device will scan, detect all the networks that is near him, and then decide which one you want to join. So if, for example, you put one pan coordinator for, I don't know, every 500 meters, then normally you should not have more than 500 meters trying to connect to a given pan coordinator, because they will try to connect to the nearest one. So how many nodes a pan coordinator will have to manage will depend on how many pan coordinator you are deploying, basically. And on terms of protocol itself, the limit is 30,000 nodes per network. But in practice, the limit will be lower due to basically memory consumption in the pan coordinator. So, but you could support 1,000, 2,000 nodes on the pan coordinator without issue. You will need to configure correctly the Bootstrap attempt retries in order to not flood the network too much. But there is already a recommendation how to configure that in the Alliance white paper.
Okay, thank you, Vincent. Another question, which is maybe linked to this one, is would routing traffic not exhaust communication allowed by duty cycle? Does anybody want to answer or add to the reply from Vincent? So would routing traffic not exhaust communication allowed by the duty cycle?
I mean, maybe I can add then, but I think Vincent mentioned it, or somebody mentioned it in the presentation, that actually the duty cycle becomes one of the metrics, if you like, for the link cost, directional route cost formula. So in the PLC links, we have penalties, if you like, for modulation of choice, or whether number of hops away from the pan coordinator. With the addition of the RF, then we've introduced the mechanism where duty cycle consideration is considered. So when links are formed, then this is automatically taken into account.
Okay, thank you, Kevin. I think we covered most of the questions. Or did you see any other ones, Cedric, we need to address?
Yeah, I think that I actually tried to answer most of them. Hopefully, you got the answers you wanted. But of course, I mean, we stay, of course, online maybe a few more minutes in case there are questions coming in.
Yeah. If you have any further questions, please post them, and we will answer them maybe after the call even. There is further information available about the hybrid solution on our website. The hybrid specification, Cedric explained, will soon be published by ITU. Until that time, it's published for the members on the website of the G3 PLC Alliance, as you can see in the link here. And we also have developed several user guidelines about specific aspects of the G3 PLC technology. And one of these user guidelines, which will be published soon, is an introduction to the hybrid PLC and RF profile. And that one will be available to anybody. Similar to the introduction, we wrote about G3 PLC and important considerations for the certification. And there are several other user guidelines available on the website for members or under development and will be available later this year. So I want to thank all of you for participating in this session today, and especially, of course, the presenters for their presentations. It's a really fascinating hybrid technology, I think, combining the best of PLC and RF. And I hope the session was useful to all of you, and you will develop many products and application based on the G3 PLC hybrid technology in the future. If you have any questions, please do not hesitate to contact me or any of the people presenting today, and we will come back to you. There will be a short survey when you leave the webinar for suggestions about other topics we could address in future webinars. So please, if you have any suggestions, please let us know. And then, well, again, thank you very much. Have a good day, all of you, and hope to talk to you again soon. Thank you very much.